It is my pleasure to welcome back Mr. Munkh-Uchral Erdenebat, if I'm saying that correctly, who will be describing a mobile integral imaging display. You can go on up, don't be shy. He's a researcher at Chungbuk National University in South Korea, where he has quite an impressive background of research papers in holography and other forms of three-dimensional display. So please welcome our speaker.
Okay, thank you for the introduction. My name is Munkh-Uchral Erdenebat, not Munkh-Uchral, and I'm from Chungbuk National University from South Korea. And it's my great pleasure to come this very wonderful place and present our research project to all of you. And I hope you will enjoy my presentation. And today's my presentation is titled as the Mobile Integral Imaging Display Using Three-Dimensional Scanning. And the contents of my today's presentation is here. It's very simple. The first I will introduce about conventional integral imaging and computer-generated integral imaging technique, and then I will explain about the background research related with the proposed method. And finally, I will explain the proposed method in detail and present some experimental results. The previous speaker has already explained about the integral imaging display in detail, so I want to skip this very detailed explanation. And one of the very important thing is when the elemental image array is captured through the lens array, it includes the three-dimensional information of the objects, that parallax and depth and color and texture information. But the special parameters, such as the field of view and depth field, are limited by the specification of the lens array. And one of the biggest issue is the low image quality caused by the imperfect matching of the optical device and aberration of the lens array. So, especially for the imperfect matching of the optical device and lens aberrations, the computer-generated integral imaging is a distinguished solution. In this case, the pickup process of the integral imaging can be proceeded through the computer generation. So the generated elemental image has the perfect quality, and accordingly, the reconstructed three-dimensional image quality can be improved. So the most of the recent integral imaging displays are based on the computer-generated integral imaging scheme. But the issue of this scheme is that three-dimensional information only can be acquired from the virtual object that doesn't exist in the real world. So it's necessary to find how to acquire the three-dimensional information of the real object through the computer-generated integral imaging scheme. So recently we proposed the simplified integral imaging pickup scheme that using the depth camera instead of the optical lens array. In this case, the depth camera, which consists of the two kinds of image sensors, the IR sensor for detection of the depth and the RGB sensor for detection for the color information. And these two sensors acquire the real three-dimensional information of the real object simultaneously, and the elemental image array is generated from the acquired depth and color information. In this case, the user must input the information of the lens array, such as the number of the lens and the focal length of the lens array and the size of each elemental lens. Also, the pixel pitch of the display device should be improved by the user. At least the computer-generated integral imaging method generates the elemental image array through the computer generation, and the optical lens array reconstructs the three-dimensional image from the EIA. So, here are the examples of the acquired color and depth information and the generated elemental image array from this acquired three-dimensional data. In the experiment, we used the Xbox 360 Kinect sensor as a depth camera, which consists of the IR projector, color RGB sensor, and IR sensor. In the experiment, this figure shows that the 5 different viewpoints of the reconstructed three-dimensional image. So we can see that the simplified integral imaging pickup method is an effective way to acquire the three-dimensional image of the real object through the computer-generated integral imaging scan. Thereafter, we upgraded that system as a real-time display. So in this case, the OpenCL parallel processing method that using the GPU parallel processing is applied in the image rendering process. So finally, we can obtain the real-time object, real-time display. In this case, each pixel of the elemental image array is corresponded to the single thread in the OpenCL kernel. So all of the pixels of elemental image array can be processed through the GPU cores at the same time. So at least the elemental image arrays can be generated rapidly from the moving objects. The elemental image array buffer size can be calculated by using these equations. In the experiment, we also use the same Kinect sensor as a depth camera, and we could display the moving object, three-dimensional animations from the moving object with 16 frames per second. But these two kinds of systems can be processed through only the PC-based image processor. So we need to find how to apply these systems into the mobile device, because the mobile device has become the most useful device in the nowadays. So we proposed our proposed methods, general schemes here. When using the depth camera as a three-dimensional scanning, now we can acquire the real data, the depth, color, and parallax data of the real object, and the elemental image array can be generated in the mobile device. And finally, the mobile display displays the three-dimensional reconstructed image. The most important feature of this scheme is especially the very low performance of the mobile device, the preprocessing stage and the digital reconstruction method cannot be processed in the mobile device. So that's why we did additional cloud computing process. So in the preprocessing stage, we should normalize the acquired depth data into the depth of field of the lens array, because most of the acquired depth data is much wider than the depth of field of the lens array that can reconstruct the three-dimensional image properly. So by using this equation, we can normalize the entire overall data of the real object to match the lens array's depth of field. Also, when we using the optical reconstruction method, we should convert all of the all of the depth data of the object points, because pseudoscopic image problem can be caused. But when we're using the digital reconstruction method, this depth conversion process isn't required. And in the elemental image generation, first we generated these kinds of virtual environment, which consists of the virtual 3D model with the normalized depth data, the virtual lens array information with the input specification, also the expected elemental image array plane with the expected resolution. The expected resolution of the elemental image array can be calculated by these simple equations. But in the mobile-based image processing, it cannot be utilized the GPU parallel processing scheme. So that's why we found out that EIA generation method within the possible short time. We chose the multi-threading method and the elemental image generation process. In this case, each elemental image is corresponded through the single thread, but these threads cannot be proceeded simultaneously. And the first few threads are processing, and other threads are ready to run mode. When the first threads are processed completely, they are blocked, and the next threads, which is in the ready to run modes, are processed. And this step is iterated to all of the threads. And finally, we can obtain the elemental image array. So in the reconstruction, we have two choices of the reconstructed method. First one is optical reconstruction using the lens array. In that case, the generated elemental image array is directly displayed on the mobile device, while the lens array is located just in front of the mobile device. But in this case, we can obtain the full parallax and continuous viewing true color three-dimensional image through the lens array, but the touchscreen feature of the smart mobile device cannot be utilized, and according to the limitation of the basic lens array, basic integral image method, the only middle portions of the total required field of view and depth of field of the three-dimensional object can be observed. But in the digital reconstruction method, the generated elemental image isn't displayed directly on the mobile device. Instead of it, the orthographic-view image and depth slice are reconstructed from the elemental image array, and each of them is displayed one by one according to the user interaction. So in this case, the full field of view and depth of field of the object can be displayed, and also the user can select the desired viewpoint, directional view image, or the depth slide. But as mentioned earlier, the modern mobile device has a very low performance but for the generation of the digital reconstruction method. So we need the additional cloud-based image processing method. In the experiment, we used the Intel RealSense F200 depth camera as a three-dimensional scanning. In the experiment, the object has fixed, and the depth camera has scanned the three-dimensional information of the fixed object by shifting the ways. And for the mobile device, we chose the Dell Venue 8 tablet PC, and this figure shows the host program of the user interface of the host program on the mobile device. And the experiment, we also applied the additional PC server instead of the cloud computing, because as mentioned earlier, our mobile device has limited performance for the preprocessing and digital reconstruction steps. In the experiment, we used three kinds of real objects: the statue, a girl, and girl with the statue. She is our lab mate. So by scanning the three-dimensional information of the real object, so we can get very large numbers of the object points for each object, and the elemental images are generated like this. From this elemental image, first we verify the optically reconstructed three-dimensional image for each object, and especially in the object 2 and object 3, the occlusion of the object points was the one of the issues, and so we should consider this kinds of issue in our next research. First, for the digital reconstruction, first we reconstruct the orthographic-view image for each 3 objects. And in this case, the 14 by 14 sub-image has been generated with the 150 by 150 pixels. For the depth slice, we also generated the 11 depth slice for each object, and the depth range of the reconstruction was 5 millimeter. And each depth slide consists of the 1,500 by 1,500 pixels. And we also compared the proposed method with the previous depth camera-based integral imaging pickup methods. In the proposed method, we fix the object and scan the 3-dimensional information, but in the previous methods, the depth camera is fixed and object was the depth and color image was captured by the lens array. And it's a very small difference, but this small difference can give us the very high accuracy and good image quality. And one of the issue of the proposed method is a long computation time because of the large number of the object point, and currently it's difficult to implement with the real-time display. Yes. So let me conclude my talk. We proposed the mobile integral imaging display system using the 3-dimensional scanning method. And this 3-dimensional scanning method gives us an opportunity that acquire the more accurate 3-dimensional information of the object. And acquired data should be normalized for the given lens array specification, and the elemental image array is generated from the 3-dimensional model through the multi-threaded method within the mobile device. And we recommend that the digital reconstruction method is more optimized for the applications. But because of the low performance of the mobile device, the additional cloud or PC-based image processor should be required. And so we need, actually we should do a lot of works. And first of all, we should complete the network-based processings. And also we should improve the image quality and improvement for the computation speed and so on. This is the end of my today's talk.